As an Antarctic scientist, I deal with bits of Antarctica that they send back to me every year. So they go down there for just the summer, and usually in about March I get sent new samples.
Hi, and welcome to Trashy Science's Trash Talk. I'm Lawrence, and with me here is Sally Crane from Ferrari's Lab at the University of New South Wales.
So we don't have to in the future go remediating and finding bacteria to break down pesticides that are stuck in the soil or to fix up overuse of fertilizer. I think if you're a hobby gardener, consider if you can grow different plants that are happy with the level of fertilizer or can deal with pests rather than using heavy amounts of pesticides or sprays on your plants to grow them beautifully, or dumping a huge amount of fertilizer, which, as we've seen, can lead to nitrite buildup and toxic soil.
Sally, can you tell us a bit about what you do in the lab?
Okay, so I am a PhD student with the Ferrari Lab. We're mainly an Antarctic microbiology lab. We do all sorts of things to do with Antarctic microbiology, whether it's discovering new species, whether it's looking for novel antibiotics within those species that we discover. And my particular field is bio-remediation, which is using bacteria to clean up oil spills. And my particular project at the moment is around a study down in Antarctica. They've got some big oil spills on soil there. They've excavated them and they've put them in big piles so that the oil is contained and not continuing to leak into the ocean. And they've mixed it with fertilizer to stimulate microbial growth. So you've got the carbon to nitrogen to phosphorus ratio that makes bacteria happy. That's why they add the fertilizer. And so they've been monitoring that over it's been going 5 to 10 years now. And my particular research is about what the microbial community changes like over time. So over the time that the diesel fuel is degraded. I look at that community changes over time and particularly focus on why in some cases nitrite's building up. After about 1 to 3 years, nitrite starts to accumulate for some reason, and that is toxic as well. Not quite as toxic as diesel fuel, but it's toxic as well.
So it's toxic to the local communities or to us?
Both. Yeah, luckily there's not many people down there eating soil. Couple of them maybe. So it's more in Antarctica, you've got penguins and things like that, but mainly you're worried about the soil community because in the end there's like a very small percentage of Antarctica is soil. And it's about, I think, 0.1% of the whole landmass is actually ice-free soil. So if soil becomes contaminated, that's a big problem for them because they're really limited in where their buildings are and things like that. So the end goal is to recycle this soil. So maybe not put it out in a pristine area, but use it for underneath a building. Some of it's already been reused as under buildings, under roads and things. It's a bit funny talking about roads in Antarctica, but there are roads and there's landing strips and things like that in Antarctica. So what we want to make sure is when we put that soil in, it's not going to be leaching contaminants out into the new area.
Okay, and you mentioned oil spills. How did the oil get there in the first place?
These spills that I'm working with are primarily fresh spills, so they've happened in the last couple of years. Wherever you have people living, they need their electricity, particularly in Antarctica, to keep warm. So all of the buildings there, their power, their heating are running off diesel fuel powered generators. When you're driving around, you see petrol stations that are closed down and stay closed down for a number of years. And that's for exactly the same reason. Anywhere where they're storing fuel, you always end up with some seeping, and then that fuel's contaminated and needs to be excavated and taken somewhere. For the first year of my PhD, looking into possible reasons for nitrite accumulating, because it's actually really rare. Usually you don't see nitrite in the soil. It's like when you start up your fish tank, and everyone says when you've got a new fish tank, don't put a heap of fish in there at once because they'll all die. And what happens is the fish excrete urea or ammonia, And so you'll get a peak of that. The chemical
Here we
formula here, like this, it's NH4 plus or NH3 is the more. So we have ammonium and ammonia. So these fish are excreting either urea that becomes this or ammonia, and then so you get a spike of that, and that's okay. We can tolerate that at reasonable quantities. But then that gets transformed by ammonium oxidizers into nitrite. So nitrite's the one down the bottom, and you get a spike of that. Okay. And that's what will kill your fish if you've got too many and you get a spike of nitrite. So you might have a spike of ammonia for a couple of days, a spike of nitrite for a few days, and then you'll see a few days later you'll get a spike of nitrate. And nitrate's a lot less toxic than nitrite. Okay. Then once you've got your community established, so what's requiring is you need some ammonia oxidizers to build up to turn it into this, and then you need your nitrite oxidizers to build up in the tank to turn it into nitrite. So all the different bacteria that are naturally occurring in water need to build up to sufficient numbers to be able to cope with the waste that the fish are producing.
And they build up because they're getting more food that they can turn into.
Yeah, that's it.
Okay. Yep. And then their waste is another bacteria's food.
Exactly.
Okay.
Yes. So then once you have that initial startup period, then you can start putting more fish in, because you've got the ammonia oxidizers and the nitrite oxidizers in a good kind of balance with each other, and they tend to hang out in little communities, in little clusters together, and so then you never really see nitrite ever building up in a fish tank again, because as soon as they take ammonia, they turn it into nitrite and they pass it straight on to their buddy who's living next door, who's a nitrite oxidizer. He turns it into nitrate. So you'll never see nitrite, you might see ammonia, or you might see nitrate. And that's exactly what you usually see in soil as well. If you dump a heap of fertilizer on it, you would see a peak in ammonia, and then maybe you'd see nitrate, and then it gets turned into the gaseous nitrogenous products. But you usually don't see nitrite, so it's very peculiar to us about why, after a couple of years of remediation, nitrite's building up. And what my hypothesis is that ammonia levels are at such a high level that it's actually poisoning the nitrite oxidizers and preventing them from building up. Oh, okay. So that's one hypothesis. The other one is that there is still a bit of diesel fuel left there, and while the ammonia oxidizers have gotten used to that and been able to cope with that after a couple of years of getting adapted to it, the nitrite oxidizers haven't yet had a chance. Okay. So now my research is about modeling that in the lab. Yep. And then hopefully coming up with some strategies to prevent that from happening in the future, and monitoring and changing our fertilizer.
Thank you very much, Sally. And before we wrap up, we have one more question that we're asking everyone.
Yep.
What's one realistic change that people can make at home to make a difference and become more sustainable?
So we don't have to in the future go remediating and finding bacteria to break down pesticides that are stuck in the soil, or to fix up overuse of fertilizer. I think if you're a hobby gardener, consider if you can grow different plants that are happy with the level of fertilizer or can deal with pests, rather than using heavy amounts of pesticides or sprays on your plants to grow them beautifully, or dumping a huge amount of fertilizer, which, as we've seen, can lead to nitrite buildup and toxic soil. Yeah. So that would be my tip.
Thank you, wonderful tip. So it's more change your garden to adapt to your environment
instead of
definitely adapting your environment to your garden.
Yeah, very much so. Yeah.
Lovely.
That's my tip.
Well, thank you very much for joining us, Sally.
Thank you, Lawrence.
And you've been listening to Trash Talk. I'm Lawrence from Trashy Science.